Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So, for more information, you can visit our website www.sapienceeducation.com. Today, I am going to discuss about the heat capacity, specific heat capacity, thermodynamic state variable, extensive and intensive property, reversibility, quasistatic, isothermal, isochoric, adiabatic, and isobaric process. So, one by one, I will go through all the details. So let us discuss about heat capacity. So what is actually heat capacity? So before going to the definition, we should understand what is heat capacity. Let us consider there is a material, and this material, if we apply a heat of del Q, it may be 100 joule, and due to this application of the heat, so there is a change in a temperature. So temperature change may happen. Earlier, suppose there its initial temperature, that is T initial, was 100, and after applying a heat, its temperature become 200. So the change in the temperature become 100. So the heat capacity can be defined as the ratio of the heat applied, that is 100 joule, divided by the temperature difference, that is equal to 100. So the body has a 1 joule per Kelvin. This is the heat capacity. So heat capacity is the amount of heat del Q required to raise the temperature difference of delta T, and this is called the heat capacity. And heat capacity is denoted as capital S, and unit is joule per Kelvin. I hope you have understood this. Now let us discuss about the specific heat capacity. Whenever we talk about a specific heat capacity, then it means that it is a material property. So heat capacity per unit mass. When we talk about heat capacity per unit mass, as we have understood that heat capacity is equal to change in temperature, heat applied by change in a temperature. But if this heat capacity will be divided by mass, so then our quantity will be known as specific heat capacity, and it is denoted by the small s. So the heat capacity per unit mass, and small s, it is denoted by small s, and capital S divided by m, that is equal to del Q by m into delta T, and its unit is joule per kg Kelvin. Specific heat capacity is a material property. Specific heat capacity is a material property, and it does not change with the mass of the substance. It does not change with the mass of the substance. Now let us discuss about specific heat capacity per unit mole. When we talk about specific heat capacity per unit mole, not per unit mass, then just we have to use the symbol C, and this is equal to capital S divided by mole, number of mole. So this is 1 by m into the value of heat capacity, that is delta Q by delta T, and the unit will be equal to joule per mole Kelvin. So this is specific heat capacity per unit mole. Now let us discuss one important topic, that is known as thermodynamic state variable. What is thermodynamic state variable? Let us consider this is a system, and this is maybe the same system, and it has a condition of pressure P1, volume V1, and temperature T1. So what happens if we apply a certain process, like if we apply heat, or if I will do work on the system, so there may be a chance to be change in a pressure, that is pressure may become P1, and the volume may become V2, and temperature may become T2. So the characteristics, how we will define that what is the characteristics of the system. So this is a system, and it has having a gas inside it. So what is the condition of this gas? So we will always able to find out the condition of gas by pressure, volume, and temperature. So these three things are required to define the state of the system. So when after certain process will go, like heating, like work done on the system, so what happen, its pressure, volume, and temperature may changes. So at a time, all three characteristics may changes, or any one or any two will changes. So this pressure, volume, and temperature is used to specify the state variable, specify state in the thermal equilibrium. So I hope you have understood this. Now thermodynamic state variable, it means the property required to specify the characteristics of any gas at a particular condition. So this is the proper definition. If you want, then you can state it like this. It means the property required to specify the characteristics of any gas at any particular condition. So how you will say that what is the condition of the gas? There is a piston cylinder and there is another piston and cylinder. How you will define the property of this gas inside the both piston and cylinder? So only characteristics we will able to define is either by pressure, volume, temperature. Here also pressure, volume and temperatures are required. So the change in a variable happens as per the given relation. Yeah, definitely. If there is a certain state variable like P1, V1 and T1 is the condition, and if we apply some of the certain process, so it will get converted into pressure P2, volume V2 and temperature T2. So what actually happened? There is a change in the state, and the change in a state follow this rule, and this is known as PV relation. This is known as PV relation. PV is equal to mu RT, where R is the gas constant and mu is the number of moles. So this is the relation will be used to find out. As per this relation only, this pressure and volume will get changes. Now there are two types of properties state variable if we want to categorize. So types of state variable, that is thermodynamic properties, are first of them are extensive property and second is intensive property. So what actually extensive property means? It depends upon the mass of the matter. For example, the body, this is a body, it has a weight of 100 Newton. If we increase the matter inside the body, so its weight is greater than 100 Newton. Its weight become greater than 100 Newton. It may be 1000 Newton. So it means that this quantity weight depends upon the matter. If we increase the matter, so volume may increase. So this also depends upon the mass of the matter. So the property which depends upon the mass of the matter is known as extensive property. At the same time, the property which is independent of the mass of the matter. For example, if you take this water, and if you want to find the temperature, so temperature, suppose we have got temperature is equal to 100 degrees Celsius. If we take this portion water, and if you want to find the temperature of this portion of the water, it will remain same. It means that no matter how much matter size is there, so it is independent of the mass of the matter. So pressure, temperatures are the property which is an intensive property. I for intensive, I for independent. So in this way you can memorize this. So this is the trick to memorize this extensive property and intensive property. You may see some of more example in your book or textbook. Now let us consider what is thermodynamic process. What is thermodynamic process? When the system undergoes a change from one thermodynamic state to another. When the system undergoes change from one thermodynamic state to another due to change in a properties like temperature, pressure and volume etc., then the system is said to have gone through the thermodynamic process. So it is not a property, it is a process only. So I hope you can understood this is not a process, this is a this is not a properties, this is process. Now let us consider how to understand these things. Let us consider this is a system 1 and it has a state of pressure P1, volume V1 and temperature T1. Okay. So I will give you an actual example. Let us consider there is a piston and cylinder. There is a piston and cylinder. So this is a piston and this is a cylinder, and there is a gas inside this cylinder. So these are the gas molecules inside the cylinder. So these are the gas molecules. And now it has a properties like P1 pressure, V1 volume, T1 temperature. What happens if we apply a heat on this piston cylinder? So if we apply a heat, certain amount of heat del Q, so what will happen? There will be change in the property. And due to change in a property, what will happen? Due to change in a property, what will happen? Due to change in a due to change in a energy, what will happen? Property may changes. So the property at this point may come here, like a pressure may be P2, volume may be B2, and temperature will be T2. So the state from state, this is the state 1 of the gas, and this is state 2 of the gas, So these are the molecules, gas molecules like this, and this is a piston. So what actually happens here? The state 1 gets converted into state 2, and this happens due to the external agent like a heat. It may be that there will be work if we apply a pressure from outside like this. So there is an exchange of energy like heat as well as pressure, heat as well as work. So due to this, what happened? It state from 1 to its state from 2. It become, and the process occurring between this meet, there is a certain process due to which this is happening. So this process is known as thermodynamic process. There is a certain things will happen before going to the state 2. So there is a mid portion between state 1 and state 2 is known as process, and this process is known as thermodynamic process. I hope you all people have understood this. Now what is thermodynamic cycle? uh, any closed, let us read one time. Any closed system that undergoes various changes due to temperature, pressure and volume, however its initial and final state will be equal. So let us consider this is a piston cylinder only, and there is a gas inside it. This is a gas inside it. Now after applying a force or a heat will be applied like del Q. Work will be done by del W. So there may changes. So but the system is closed and no mass transfer happen because system is a closed systems. So at this stage there is a pressure P1, volume V1 and temperature T1, and the internal energy U1. At this stage also we have seen that pressure will P1, volume will be P2, pressure volume will be B2, temperature will be T2 and internal energy will be U2. But what actually happens here? P1 will become equal to P2, V1 will be equal to V2 and temperature T1 will be equal to T2 and U1 will be equal to U2. Then this is known as thermodynamic cycle. If you want to see in a graph, so if we go through the graph, so this is the graph, this is the pressure and this is the volume graph, and let us talk about the state. So this was the state of 1 of the thermodynamic cycle, and this is the state 2 of the thermodynamic cycle. So when it process undergoes, so it come to the point state 2, and again it goes to the state 1 only. So there are whole cycle, and this closed cycle is known as thermodynamic cycle. In this, what happened? The internal energy U will remain same, that is U1 is equal to U2. So finally what will happen? finally what will happen? Change in internal energy will be 0. So it may be that why I'm telling pressure 1 and P1 is equal to P2, it's because it is the final state. It's a final state. Final state. So this may, you may take this point as a O or something else. See, pressure 1 and 2. See here, pressure at 1, and when it comes again to the same position, then the pressure 1 is equal to pressure 2, volume B1 is equal to B2, and temperature T1 is equal to T2 happens. And this complete cycle is known as thermodynamic cycle. Now let us discuss about the reversibility. Reversibility. In a thermodynamics, a characteristics of the certain process that can be reversed and the system restored into its initial state without leaving a net impact in any of the system involved. So let us practically experience what happens. Suppose there is a person standing on the road. If a person goes from this point 1 to point 2, so he will use this footprints. So he may use this footprint. Now if person reached here, now if I will tell this person that you have to go into its initial state by same footprint, so what will happen? There may be a mistake that it's one of the foot may happen here. It is not possible every time that it will use the same footprints. But if it use the same footprints, then what will happen? It will, this type of process is known as reversible process. Or you can also use the paper. This is a paper, and if you burn this paper, so what will happen? It will become ash. It will become ash. You can't reconvert to the paper. So this is a irreversible process. But when what will happen when we melt ice? Suppose this is a ice, and ice gets ice melts into water, and if you want to reconvert water into ice, so it will get converted without changing any, leaving any net effect in the system. Net effect, what do you mean by this? Suppose this is a state, and this is a state 1, and this is a state 2. It has certain pressure, volume, temperature. It has also certain pressure, volume, and temperature. So when we convert this characteristics from state 1 to state 2, so we have to apply a heat, that is Q is equal to 100 joule. Now if we reconvert this state from 2 to 1, so it must absorb Q is equal to 100 joule. Then the process is called reversible process. At the same time, if it is doing work, if it is work is done on the system of 50 joule, so when we reverse, so this system must do output work of 50 joule. So what will happen? The net energy will be 0. Q net will be 0. Why? Because there will be 100 minus 100, that is equal to 0. Work net will be equal to 0, because 50 minus 50, that will be 0. So the overall net energy leaving out of the system is 0. So the thing is that we need to understand that whenever there is a net energy transfer is 0, then only the system is known as reversible system. Reversibility. Then the process is known as reversible process. Now let us talk about the types of process. There are 5 types of process. One is quasistatic process, another is isothermal process, third is isochoric, adiabatic, and isobaric. So we will details study each and every process. Let us understand what is quasistatic process. When a process is processing in such a way that the system will be remain infinitesimally close with the equilibrium and the state at each time, such a process is termed as a quasi-static process. Let us consider if a person is walking for a 2 step. So what will happen when the person move from one step to second step? So if I will tell the person just go back on the same path, so he will go back. So this state is known as equilibrium. Why equilibrium? Why equilibrium? Because there is no net impact on the outside of the system is happening. So see here, if there is a body having a temperature of 101 degrees Celsius, and there is a body having a temperature of 100 degrees Celsius. So when we touch this body, so what will happen? There will be a transfer of a heat. So we can also reverse this. So what happened there? If we take any small steps, then only we can reverse this. Or you can also see that there is a water inside this, and it is this container is packed. So water gets converted into vapor, and vapor again gets converted into water. So this is the cyclic process, and there is no net effect on the outside of the system. So this is known as reversible process only. So reversible process only happen when we take a small steps. If we take suddenly a long step, so we don't know which path is following. For example, if we make a graph and process PV, and there is a state 1 and there is a state 2, which is very large leap. So what will happen? It may take this path, it may take this path, it may take this path. But we actually don't know which path they are following. But if we take a small step like one, this is a step 1 and this is a step 2. So what will happen? There is a only possibility of one path only, because it is very small. So when we take a very small, infinitesimally small, so what will happen? It is possible to make it as a equilibrium. Let us see. This is very small state 1 and 2. So the only possibility is this only. So when we take a small step, so what will happen? See here in the process, actual example of quasi-static process, what happened? We slowly remove the top weight with a very small mass or a small weight. So if we will remove a small weight, so what will happen? Its state come from 1 to A. Again it may go back. If we again keep the same weight, so what will happen? Our condition of a P1 V1 and temperature T1 will again come to the same state, because we are taking a small step. So small step, if we take a small step, then only what will happen? Then only it will remain in a equilibrium. So we are going like this up to 2. So when we join this line, so this line, the whole process is known as quasi-static process. So if we go to the definition again, so when the process is processing in such a way that the state will be remain infinitesimally close with the equilibrium state. See here, because we are taking a small path, and each time such a process is termed as a quasi-static process. So I hope you have understood the quasi-static process very well. Now let us consider isothermal process. So what is actually isothermal processes? It is a thermodynamic process in which temperature of a system will remain constant throughout the process, but the process pressure, volume and other factor will change. So whenever this happens, then this process is known as isothermal process. So let us consider there is a piston cylinder and there is a gas. If we apply heat, so what happen? Its pressure may changes, volume may changes, temperature may change. Pressure and volume may changes, but temperature will remain constant. Whenever temperature will remain constant, then this process is known as isothermal process. Iso means constant, and thermal means temperature. So this is a isothermal process. If we draw a graph between pressure and volume, so isothermal process will be like this. So A to B is an isothermal process, and C to D is also an isothermal process. So these are the graph of the isothermal process. Now let us consider what let us learn about isochoric process. Isochoric process, a thermodynamic process in which the volume of the system will remain constant throughout the process. So let us consider iso means what? Iso means constant, choric means volume. So if volume will remain constant, then that type of process is known as isochoric process. Let us consider again the piston cylinder. There is a piston and there is a gas inside this. And what happened here? Here I have used a block in such a way that no matter how much we apply a heat here, how much apply a heat, it doesn't matter. So its volume will remain constant. Why? Because we have used the stopper. So when we use stopper, so what will happen? Pressure may changes, pressure may increases, temperature may increase, but the volume will remain constant. And this type of process is called isochoric process. So I hope you have understood. Now next is the adiabatic process. Adiabatic process. It is a thermodynamic process in which the pressure, volume, temperature of the system vary throughout the process, but that there is no exchange of a heat from the surrounding. Let us take let us take a piston cylinder process only. This is a cylinder and this is a piston, and there is a gas inside it. So when we heat inside, so what will happen? Heat will go inside it. But we have to make situation such a way that no heat should transfer from outside or inside. So there is no exchange of heat. So if there is no exchange of heat, so what will happen? Process may changes. So everywhere we have blocked the heat transfer. So if we block the heat transfer and if we apply a force here, so work will be done. So due to work, what will happen? Pressure may change, volume may changes, temperature also may changes, internal energy may changes, anything may changes. But what will remain constant? There is no exchange of heat. So heat will not get transferred. Okay, so this type of process is known as adiabatic process, in which change in heat is should be zero. And if we see the graph of adiabatic process, so graph will appears as a to, suppose this is a to b, or this is a c to d. So these are the graph of the adiabatic process. So in PV diagram or in a PV graph, we will be able to relate this adiabatic graph like this only. So if it is thermal, so this is isothermal, and if it is like this, so this will be an adiabatic graph. So I hope you have understood this. Now let us consider isobaric process. So what will be the isobaric process? Uh, Isobaric process. What happens here? It is a thermodynamic process in which the pressure will remain constant throughout the process and the rest state variable changes. Let us make a diagram. So there is a gas inside it, and let us consider there is a pressure is equal to 1 Pascal or 5 Pascal. So when we heat up, when we apply a heat from inside, so what will happen? The pressure may increase, but due to increase in a pressure, as pressure starts to increase from 5 to 5.01, so what will happen? Due to the movable piston will go up. So here volume may changes, temperature also may changes, but what will remain constant? Pressure will remain constant. And in this type of process, it is known as isobaric process. So I hope you have understood this. So thank you for joining my classes. So if you want to go study more and more in my class, so you can be connected with the YouTube channel. And thank you.